All right, so on number one, you're supposed to graph the function and its inverse and state the transformations for each function. So this first one is a cubic function, and it has a vertical compression. It's on the outside of the parentheses by a factor of 1/2, and it goes to the right 4. So when I think about my cubic function, y equals x cubed, the general function looks like this, yeah? And then I use the pattern. Over 1 up 1, because 1 cubed is 1, over 2 up 8. And the next number would be over 3 up 27, although I don't think we'll see that. So it goes left 1, down 1, and left 2, down 8, normally. And then, because there's a vertical compression by a factor of 1/2, we're going to multiply the vertical lengths by 1/2. So this would be 4, this would only be 0.5, this would be 0.5, and this would be 4. Half of 27 is not going to be small enough for me to see on this graph, so we'll go ahead and graph just those 5 points, because you got the center point, right? So to the right 4 is my center point, and I'm going to go over 1 and up 1/2, and then I'm going to go over 2 and up 4. 1, 2, 3, 4. I'm going to go left 1 and down 1/2, and then I'm going to go left 2 and down 1, 2, 3, 4. Now, as far as the next point goes, you're not going to be able to see it, right? So what you need to be careful about is don't go past this line right here, okay? So when I sketch this, I'm going to go arch down and then do that, and then come back up and go here. And it's okay if you stop right there. Just don't cross through that line, because you can't. It would be past this 12. Okay? Now I'm going to graph the inverse. So first I got to find the inverse. So if I start with x equals 1/2 quantity y minus 4 cubed, then I'm going to solve for y. So I'm going to first take care of the 1/2 out front. So the opposite of multiplying by 1/2 is to multiply by 2. So I'm going to multiply both sides by 2. This simplifies out with that. So I'm left with 2x equals the quantity y minus 4 cubed. The next thing I'm going to do is undo the power of 3, which is with the cubed root. So I'm going to take the cubed root of both sides. With the cubed root, you don't need to worry about plus or minus, so it's the cubed root of 2x equals y minus 4. And the last thing I'm going to do is add the 4. So the cubed root of 2x plus 4 is f inverse of x. Okay. As far as transformations go, let's see. The 2 is in the interior with the cubed root, or inside the cubed root, which means it is acting on x, which means it's a horizontal change. So for this, we would call this a horizontal compression by a factor of 1/2. Remember, take the opposite on the interior. But just something to keep in mind, if this one has a vertical compression by a factor of 1/2, then this is going to have a horizontal compression by a factor of 1/2. It's always the opposite, but it's the same. So opposite in that if it's vertical, it's horizontal, but same in that it's a compression by a factor of 1/2. So maybe that helps. Okay, so in general, I'm going to think about and then up 4. Okay, so my general cube root function looks like this. Yeah, so you got the cubed root of x in general looks like that, which means my pattern is over 1 up 1 over 8 up 2. Cubed root of 1 is 1, the cubed root of 8 is 2. To the left 1, down 1, to the left 8, down 2. But we're horizontally compressing by a factor of 1/2, which means I'm going to compress the horizontals by 1/2. So I'm going to go to the right. So first I'm going to go up to my starting point, up 4. And then I'm going to go to the right 1/2 and up 1. And then I'm going to go from the starting point again to the right 4. 1, 2, 3, 4, and go up 2. Now I'm going to go to the left 1/2 and go down 1. And then I'm going to go left 4, 1, 2, 3, 4, and down 2 from my starting point again. Alright, so if I connect those like this, and again, I would not be able to see the next point, so I just need to kind of draw an arrow. And then something like that. And then if I want to make sure that it's definitely the inverse, the reflection, then I'm going to draw a line from diagonal to diagonal. And remember, this is -6, 6 right here. This is 12, 12 right here. So I'm going to connect those 2 points. And as long as your graph is a reflection across that line, then you're good. Okay? And that definitely looks like a reflection. So we're good. All right, number 2. We've got the cubed root of 2x plus 6 minus 5. So I remember that anything in front of the x in the interior needs to be factored out. So it's the cubed root of 2 times the quantity x plus 3 minus 5. Which means we're going to go to the left 3. We're going to go down 5. And we're going to have a horizontal compression by a factor of 1/2. Okay? So, cube root function, similar to this one right here. I'm actually just going to go ahead and use this right here because it's just a horizontal compression by a factor of 1/2. So I'm going to go left 3 and down 5. Left 3 and down 5. And that's my starting point. And then I'm going to use this pattern because it still has the horizontal compression by a factor of 1/2. So I'm going to go right 1/2 and up 1, right 4, 1, 2, 3, 4, and up 2. Left 1/2 and down 1. Left 4, 1, 2, 3, 4, and down 2. So there's that, and then there's that. Okay, and then I'm going to find its inverse. So x equals the cubed root of 2y plus 6 minus 5. So I'm going to add the 5. I'm going to cube both sides. So if I cube both sides, not with that one. And that simplifies out with that. So now the x plus 5 quantity cubed equals 2y plus 6. And then I'm going to subtract 6. So x plus 5 quantity cubed minus 6 equals 2y, and then I'm going to divide by 2. But dividing by 2, I could write divided by 2 and divided by 2. But what I'm actually going to do is say 1/2 the quantity x plus 5 cubed minus 3. And that's going to be f inverse of x. Okay. So this is a cubic function, and the cubic pattern is over 1 up 1, over 2 up 8, left 1 down 1, left 2 down 8. And this is a vertical compression again by a factor of 1/2. So the vertical compression. Notice how the 1 and the 8 were the ones compressed, not the 1 and the 2. It's the same thing with this, the 1 and the 8. So it's the same numbers that should be compressed. Okay, so I'm going to take my transformations, which are left 5 and down 3. Left 5 down 3, and then apply the compression. So left 5 down 3. Okay. I'm going to go to the right 1 and go up 1/2. I'm going to go to the right 2 and go up 4. 1, 2, 3, 4. I'm going to go left 1 and down 1/2. I'm going to go left 2 and down 1, 2, 3, 4. Oh, okay, so say it's not the same. Not the same grid. Okay, so I have one more thing. I might be able to see the next one, so let's go ahead and 3 cubed is 27. So half of 26 is 13, so 13.5. So if I'm down 3, well, it'll be just past it. I go over 1, 2, 3, and go up 13.5, so this would be 13.5. But anyway, just to kind of get a view of what it would be, how far it would have to go up in order to reach that point. So we'll be down here, and then up, and then if you want to go up to this point, feel free, but you don't have to. 27. You're welcome. So, just make this clear. Okay, and again, I'm going to draw my diagonal just to make sure, although it definitely looks like a reflection. And this is negative 8, 8, so I can go from corner to corner. So corner, corner, Again, switch our semblance. Okay, and that definitely looks like a reflection. All right, let's go to number 3. Number 3 is a cube root function again, but this time it has a negative in the exterior, which is flip over the x. It has a 3 on the outside, which is a vertical stretch by a factor of 3. Right 2 and up 4. So I'm going to go right 2, up 4, flip over the x, vertical stretch by a factor of 3. Which remember, that means to me that I'm going to have a horizontal stretch by a factor of 3 on the inverse. And then, yeah, that's it. Okay, so I'm going to go right 2 and up 4, right 2 up 4, and no matter what, like that's always going to be my starting point. Your shifts tell you what your starting point is. This tells me the direction, and this tells me the shape of it. So flipping over the x means instead of the cube root function looking like this, it's going to flip and look like that. Okay, so I know that my pattern is now to the right and down. Okay, so let's cube root, so right 1, down 1, the right 8, down 2. Remember, we're talking about cube root. The cube root of 1 is 1, and the cube root of 8 is 2. Left 1, up 1, left 8, up 2. And the other one would be over 27, but there's no way we're going to go to the right 27. Okay. There is a vertical stretch by a factor of 3. So that means these heights. Okay, so vertical stretch, which means instead of going down 1, we're going to go down 3, and instead of going down 2, we're going to go down 6, because we're going to multiply by a factor of 3. So 3 and 6. Okay, so I'm going to go from my starting point, right 2 up 4, right 1 down 3, right 1, 1, 2, 3. I go right 8 and go down 6. So this is a 2, which means I'll be at 10, and down 6, which puts me at negative 2. Okay. I'm going to go left 1 and up 3. So 1, 2, 3. I'm going to go left 8 and up 6. So I'm at 3, so negative 5. And up 6 from 4. That puts me up at positive 10. Yeah, negative 5. Okay. So always from the starting point. Left 1 up 3, left 8, up 6. So it looks something like this. And always make an effort to actually go through the points that you plot. There definitely needs to be a good faith effort made. So let's spin this right quick to sketch it. Okay, there's my original. And now I'm going to find my inverse. So x equals negative 3 times the cube root of y minus 2 plus 4. So the first thing I'm going to do is subtract 4. Negative 3 times the cube root of y minus 2. Then I'm going to divide by a negative 3. Dividing by negative 3 is multiplied by a negative 1/3. So multiply by a negative 1/3 on both sides. And that will simplify out the negative 3. And I'm left with the cube root of y minus 2. I'm going to cube both sides. And then I'm going to add 2. So negative 1/3 times x minus 4 quantity cubed plus 2 equals my f inverse function. Okay, so one thing that gets people kind of confused is that this right here is in the interior. I could distribute my negative 1/3, but I like to leave it like this because it shows me the transformations more easily. So as far as transformations go, we're going to flip over the y. This is a horizontal stretch by a factor of 3. And remember, the inverse and the original should have the same kind of thing. It's a stretch by a factor of 3, just direction is different. We're going to go to the right 4, and we're going to go up 2. So I'm going to go to the right 4. If I go to the right 4 and up 2, now this is a cubic function, right? So normally a cubic looks like this, but the reflection over the y means it's going to look like this. Okay, so when I draw my pattern, I'm thinking to the right and down. So cubed. So 1 cubed is 1, 2 cubed is 8. 1 cubed is 1, 2 cubed is 8. But this is a horizontal stretch by a factor of 3. So instead of going to the right 1, we're going to go to the right 3. And instead of going to the right 2, we're going to go to the right 6. Instead of going to the left 1, we're going to go 3. And instead of going 2, we're going 6. So from my starting point, which is right 4 up 2, I'm going to go to the right 3 and down 1. So to the right 3, 1, 2, 3, and down 1. And then I'm going to go to the right 6, and I'm going to go down 8. So right 6 from 4 is 10, and down 8 from 2 is negative 6. Alright, then I'm going to go to the left 3 and up 1. So left 3 and up 1. And I'm going to go to the left 6 and up 8. So from 4, left 6 is negative 2. From 2 up 8 is 10. Alright. And just as a reminder, the coordinate point should actually flip. This is the point 3, 1, and this is the point 1, 3. This is the point 4, 2, and this is the point 2, 4. This is the point 7, 1, and this is the point 1, 7. This is the point 10, negative 2. This is the point negative 2, 10. So the coordinate points should just reflect each other, the x's and y's and the inverses. And again, this definitely does look like a reflection. So we are good to go. And you can always check your points. So maybe even plot your points that way. And like, I don't disagree with that being as a method, but that means you definitely have to get the first one right, because you have nothing to check up on if you're just using your original points. Okay, and that's page 1.